Hello and welcome back to Compiler Programming. A few videos ago I've added this Opaque descriptor type that should allow us to move more of the descriptor definitions into user land. And today I want to try to make one of that happen. So candidates are probably floats and integers. Integers have already a lot of code around them and not so much for floats, so I will start with that one. And the idea is pretty straightforward. I will remove this custom descriptor type and say that is no longer a thing. And instead I will make floats into Opaque types. So let's take a look at what Opaque types are and what they need to have. So they have these bit size, and that's all they do. So let's try to turn them into one. So that means that here we need to say type Opaque, and we would have bit size 32. So previously it was a byte size. Now we are multiplying that by 8. And here bit size is 64. And we are doing it this way. Yeah, it's no longer integer. It's actually already a problem, so this should not have been integer, should have been a float, but I have not done that well enough. So we are removing the float here as well. Maybe let's move Opaque to be actually first, just for convenience, doesn't really matter. And Opaque here. Okay, that's all for headers, but as you can see, there is still a lot of stuff that is problematic, so let's take care of it one by one. Okay. What does this do? Oh, we are converting float results from compile time execution into integer ones, into intermediates. That is not really necessary, and I think it was broken anyway. So that is out. Okay. Well, this has to do with immediates and floats. We were not supporting this anyway, but more general version of this would be exactly with Opaque types. Well, like we should be able to assign an Opaque type to a constant to an integer constant. Like if the bits fit, it should be fine. But for now, that's not implemented anyway. So we are just doing this and types. Yep. That sounds good. Okay. I guess the next thing is inside of function. So here we have a bunch of problems. Okay. So this is where we need maybe a few helper functions or something like that. But let's do it this way for now. So value is basically I want to have, this is type, yeah. Now I want to say bool value is floating, I guess, point or float, and it will get maybe descriptor is float. So it will get the descriptor and it'll say return descriptor is F32, or actually it's like this. Do I want to turn them into pointers right away? No, it's fine. Descriptor F32 or descriptor is descriptor F64. Okay, now we can get back to here and say if descriptor is float target or descriptor is float of source. Descriptor. Let me make it a bit bigger. Yeah, that sounds good. Okay. This makes sense so far. Let's check what happens here. And well, this is the same thing. Descriptor is float of descriptor. Good. Who else needs fixing? Okay, we have a bunch of stuff inside of value.c. So let's check that. Okay, this is no longer the case. It will be taken care of by the Opaque, where we just compare descriptors directly. Okay, here's the same thing. This will give us the right thing, I guess. Okay, value register for descriptor internal. Well, we can say descriptor is float, and the same stuff goes everywhere in here. Okay. Well, this was broken anyhow. Okay, maybe that would be much quicker video even than I thought, but that's fine. Sometimes it is that simple, but before I say that it is, let's run the tests. Well, the tests are passing, and that's basically all there is to it. I think the next thing would be to convert integers. This would be way more involved, and I thought I would do it offline, but since the floating ones were so easy, maybe I will try to tackle it right now. So before I do that, I will say episode 128 and should say turn floats into Opaque types. Okay, that works. I really like commits where we remove more than we add. That's always very nice thing. Okay, so now it's gonna be more fun because we need to do a bunch of things if we want to support integers. Thing number one is there is this isSigned thing, and I need to actually get rid of it if I want to have it working correctly afterwards. So the idea is we will not have it as a Boolean flag here. Instead, we have a similar function to descriptor is float that will take care of just checking if it is S8, S16, and so on and so forth. And it will return true for sign types. So we are getting it. Actually, let me remove isSign here before I continue so that it shows us actually where all the errors are. And we need to add a bunch of things here. So first we need to say descriptor is integer, and that's going to be a very long list of comparisons. Maybe later on it would be better to turn this into a hash lookup or something, but for now, again, I don't really care about the performance of this stuff. I'm more interested in the functionality. So just a simple list will be perfectly fine. We could also do this probably as a like SSE comparison or something. I don't know. When we get to this, it will be obvious what to do when we get to optimization phase. Okay, so this is what an integer is. And now I need to say descriptor is in which direction do I want to say? Is it a signed integer or is it unsigned integer? Is signed integer... Actually, I can probably do it that way, right? I can say this is unsigned integer and just have these ones. This is a signed integer, I have these ones. And I will have descriptor is integer, and this will be... actually, let's maybe make it right away static inline, and I will say descriptor is signed integer of descriptor, or descriptor is unsigned integer of descriptor. Okay, now we have these helper functions. That should be sufficient. Okay, what are you doing? Well, we can say if not, if descriptor is unsigned integer, okay, that actually is even more readable. I like that. Okay, now this is a bit trickier to do here. So this one is fine. It's the same thing. If it is unsigned and it's operand immediate, then yeah, we do this stuff. That's okay. And for these things, this is a bit trickier. So we are saying that if left-hand side is not the same as right-hand side, well, yeah, that's kind of tricky. Say bool is left-hand side is LHS signed, and we would say descriptor is signed integer of LHS value descriptor, and we can do the same for right hand side, and we here just compare that if something like this. Okay, I'm here missing a descriptor. And that seems to be it for now. I mean, our support for unsigned numbers is not full anyway, so it was actually helpful in this case, I guess, because there is less stuff to fix. But let's see if that still works. It does still work, so let's commit that separately as well. And we'll say episode 128, remove explicit is signed flag from integers. Instead, we are checking exact descriptors for being for descriptors as pointers. Okay, this is a bit of a worse commit because we are adding a bunch of stuff, but hopefully we will be removing it now. Or a bit later, maybe. Okay, so what are other things that are unique to integers? Well, another thing about integers, which is going to be a bit tricky to pull off, has to do with this stuff. So we need to be able to, this is done for immediates, right? And we need to be able to get the numbers as the right type in C so that we can do constant folding, any kind of calculations and all stuff and all the stuff around that. Now, a more general version of it would be that we just have some memory and we say that it is also opaque, and then depending on the type, we treat that memory as one thing or another thing. Not sure if I want to try to delve to this right now. I guess right now I will leave it as is and try to just remove the integers. And again, this will generate a lot of problems once I do this, because integers are the main type we support. They are all over the place, and that's gonna be a bit problematic. So integers go, and the same here. We basically need to switch it to Apex, right? And this one is 16, and the final one is 8. Okay, but we still obviously don't have integers. So this needs to be all opaque. Okay, everything is fine here, but obviously not everything is going to be fine in a lot of places. Let's start maybe in here. Well, this is fine, maybe. Let's actually fold it this way. Integer byte size, that goes away. That is also fine. Actually, no. No, this is not fine. Do I actually call this function? That is a big question. The function descriptor. So let me try to disable all of that, because they will probably be done in a different way later on. So we'll see. C function descriptor, C function import. Okay, that's also hopefully not required. We'll see. Okay, if source is integer, so this has to do with using 0 as a literal for integers, and This will probably be slightly different, but for now that's fine. You can say descriptor is integer of source. Descriptor. And here it's the same thing. Except that here it's target. This stuff here is now probably different. So to consider what this should be for Opaques. Or rather, no, I mean, if it is, if they're not the same, then it's fine, but this condition actually is different now. This condition is, we need to say that descriptor is integer of source descriptor and descriptor is integer of target descriptor. And actually we also need to say to do deal with signedness. I don't know. Signedness? Is it like this? I guess. I don't know. Okay. But this is not something that we're introducing with our change. This was not taken care of there previously, so I don't want to go into that tangent for now and focus on integers. Okay. If not descriptor is integer of bit size value descriptor, like that. Okay, well, here we are switching on a descriptor type. Yeah. Okay, so this now needs to go into here. Instead of checking an integer, we'll have to do it here and say if descriptor is integer of, what is it, out value descriptor. Okay, let's hope that it actually works. That is pretty straightforward. That is the same thing. Descriptor is integer. Actually, it should be is signed integer. So previously that was wrong, but it's easy for us to fix because only signed integers can be negative, right? So this should not be like it was before. Okay, if descriptor is integer, says value descriptor, easy enough. And the same thing here. Let me just grab this. Here it's not size value, it's just value. Looks good. Okay. Descriptor is integer. Integer. Great. Descriptor is integer. Value descriptor. And that goes away. Probably now put it on one line if we really wanted to. And the next one. Okay. If left hand side is not an integer or right hand side is not an integer, then panic. Okay, we can do that. Descriptor is integer of LHS value or not. Descriptor is integer of RHS value descriptor. Okay. Something like that. Good. Not so many as I expected, but let's see if it continues to work. Who else needs to check? Oh, this is already tests, which is great. That actually means that we are on a very good track, I think. Descriptor is integer. Status descriptor. Descriptor is integer. Status descriptor. Oops. Okay. Who else needs to look at that? That's the same stuff. And the same stuff here. Okay, what else? Okay, we have pointer arithmetic. But it's again the same check. Be descriptor. And be descriptor opaque. Bit size is 64. Okay, we can check that both of them are integers. That sounds pretty good. Multiplication. We're making sure that they are integers. I think I will also need to change same value type at some point. But let's see. Well, that is it for changes, but I expect that maybe I made a couple of mistakes here or there. Yeah, so something did not go completely according to the plan, but it wasn't terrible either because quite a few tests have passed. Let's open up the debugger and see what is going on with that to do. Okay, don't need this stuff. If descriptor is signed integer, so we somehow ended up with an unsigned one and then we reversed it. How did that happen? So first of all, which test is that? that is here, do I parse them as unsigned? I guess I do. So, okay, let's put it back to the way it was before, and then we will see if that is correct or not. And that was it. So yeah, I need to maybe recheck that logic, but it was like that before, and we're not changing that right now. But this actually is very, very nice, and I really like that change. That kind of shows that from the standpoint of the compiler, at least as far as all the regular handling goes, we can totally make a lot of stuff Opaque types. And then we will need to figure out what to do with things like so functions. It probably will have to stay a very specific type, I think, or maybe not. I don't know, like what to do about that. And then arrays are a bit more higher order, maybe. Structs, it's also structs and unions are like tag unions. I think I will remove them in the way they are done right now. And structs are a bit more high level, but at the same time, that is very possible that they will also be folded all into the pack thing. And then we have time descriptors and pointers. Ideally, what I want to do is in the end not have this at all, and just say, okay, I have this collection of bits, and then the rest is defined by the functions that exist on them, or kind of methods you can call it. But that is a very long-term thing. For now, I'm pretty happy with the change we made today. Now, from the standpoint of compiler, floats and integers are exactly the same thing, and we only distinguish them by exactly the descriptors that they use. And later on, that will actually mean that we should be able to just use overloads based on types, which we already have, to provide all the functionality that we need. But that will happen another time. For today, that's all. Thank you very much for watching, and hopefully see you next time.